Hello students, how are you all? I hope that you all are good and the series of basic mathematics used in physics is going on and we are successfully finished the three lectures. In a first lecture, we are discussed about trigonometric functions. In a second lecture, we are discussed about arithmetic, geometric progressions and a quadratic equation. In a third lecture, we are discussed about coordinate geometry. In that lecture, we are discussed about slope. What is the formula of slope? So where the slope is positive and negative, and all these things we are discussed in a previous lecture. That means lecture number 3. And today's session we are going to discuss about differentiations. Okay, what are the formulas of differentiation? What is the meaning of differentiation? And what are the applications of differentiation? And all these things that we are going to discuss in this session. So my name is Rakesh Kanagandi. Welcome to our beautiful physics channel, Rakesh Sir Physics. Right? Shall we start the lecture? Okay. Basic mathematics used in physics, and this is a class number 4. And today's topic is what? Differentiation. Okay. So before going to discuss about differentiation, in a previous lecture we are discussed about slopes. So in a two-dimensional coordinate system, this is what x-axis and this is y-axis. Okay, this is origin. In a two-dimensional coordinate system, a line is passing like this. This is equation of a straight line which is passing through the origin. A line is moving like this. And this line is making an angle theta with a positive x-axis at a origin. Let us say this is an angle theta. So if you observe carefully, at every point on this straight line, this positive x-axis, what is this? Positive x-axis. See, x-axis parallel to each other. Okay. At every point on this straight line, the positive x-axis will make an angle theta. Have a look. If this is theta, then this is also theta. Theta. All thetas are same. Angle made by each and every point on this straight line remains same. Where theta is what? Constant. Theta is what? Constant. Now, if you want to find the slope between any 2 points, what is the meaning of slope? The line which joins the 2 points in a given plane. So, on this straight line, I am taking here a point A, and at this point, I am taking a B. This point as B. Now, this point A is at a distance x1 from the origin along x-axis, and this point B is at a distance x2 from the origin along x-axis. Now, this point A is at a distance of y1 from the y-axis, y1 from the origin on y-axis, and this point P is at a distance y2 from the origin in y-axis. Now, what are the coordinates of this point A? x1 comma y1, and coordinates of this point B is what? x2 comma y2. Now, how can we measure the slope? Slope is equals to tan theta is equals to change in y by change in x. The ratio of change in y by change in x is called what? Slope. So what is delta y? Change in x, change in y. Okay. What is delta x? Change in x. Change in x. So what is delta y? Delta y is equals to y2 minus y1, and delta x is equals to x2 minus x1, and the slope is equals to tan theta is equals to change in y by change in x is equals to y2 minus y1 by x2 minus x1. Right? So this is what we are discussed in a previous session. Okay. So we are discussed three conditions. So first one is if theta is less than 90 degrees. If theta is less than 90 degrees, then theta is what? Sorry. Then tan theta is what? Positive. Then the slope is positive. Then the slope is what? Positive. If theta is less than 90 degrees, sorry, if theta is greater than 90 degrees, then tan theta is negative and the slope is negative. Okay, so if theta is equals to 0 or 180 degrees, then tan theta tends to 0, then the slope is constant. Then the slope is constant. This is what we are discussed in a previous session. So with respect to theta, the slope will be changes. Either it is positive, either it is negative. So with respect to theta, where in this case, right. So in this case, where theta is what? Constant. Where theta is what? Constant. If theta constant, if theta constant, then slope is also what? Constant. Then the slope is also constant. So whatever the slope between the 2 points you are taken, the slope remains constant throughout this line. Is it clear? So in this case, theta is constant everywhere, then you will get what? Slope is constant. Always you will get slope is constant because where theta is constant. If theta changes, if it is less than 90 degrees, then slope is positive. If theta is greater than 90 degrees, then tan theta is negative and the slope is negative. But the situation is different here. Theta is everywhere is constant and the slope is positive because it is less than 90 degrees. Okay, this is a y-axis, this is a positive x-axis, and theta, whatever the theta is made by this slope is less than 90 degrees, then the slope is positive. Your slope is what? Positive, but it is what? Constant. Slope is what? Constant. Is it clear? Right. So I'm taking a second graph, and the graph is like this. This is what? X-axis, and this is what? Y-axis, and this is origin O. Now the graph is like this. Okay. Now I want to find the slope at these points, given points. At a given point, I want to find the right. In a previous graph, the slope between the 2 points is same because it is a straight line. But here, whatever the line is given, it is a curved line. Okay, and I wanted to find the slope at this point. I'm just drawing a tangent which is passes through this point. Now this is what? Positive x-axis. Now take an angle theta in anti-clockwise direction up to this slope. So I'm taking what? An angle theta up to slope. Let us say this is a theta 1. Right. At this point, again I'm just drawing a tangent. Okay. So at this point, okay, this is a tangent. So at this point, I'm drawing a positive x-axis. I'm taking the positive x-axis. Now this positive x-axis is making an angle theta 2 at that point. Okay. So at a point, again at this point, we have to find the slope. What we have to do? Just we draw the tangent at that point and take a positive x-axis, draw an angle theta in anti-clockwise direction. Now this is an angle theta 3. If you observe carefully, whatever the theta 1, theta 2, theta 3 made by these points are increasing. Angle thetas are increasing. That means theta 3 is greater than theta 2 is greater than theta 1. That means what? Theta is changing. Theta is what? Changing. If theta changes, then tan theta is changes. If tan theta changes, slope changes. If slope changes, then slope is not equals to constant. That means slope is not constant. The slope is variable. So from point to point on this curved line, the slope will be changes. Now how to find the slope at this condition? Take a look. To sort out this problem, I am doing like this. So this is x-axis and this is y-axis. This is a given. Whenever you are taking the points at a distance, we are getting theta value is different. We are getting theta values will be different. I'm taking the 2 points very nearer to each other. Let us say this is point A, this is point B. Point A and the point B. Take a look. Now the slope between these 2 points is straight line. That means, so now what is the formula of slope? What is the formula of slope? Slope m is equals to tan theta is equals to x2 minus, sorry, change in y by change in x, then which is equals to what? Y2 minus y1 by x2 minus x1. So this is what? This is the formula of slope, right? So this point here is at a distance x1 from the origin on x-axis, and this point B is at a distance x2 from the origin on x-axis. This is what? Y1, distance of point A, and this is what? Y2, the distance of point B on y-axis. So now what is this point? x1 comma y1, and this point is what? x2 comma y2. What are A and B is? What are the A and B is? A and B are very nearer points. Very nearer points. Very nearer points. Are you getting? So what is the point A? x1 comma y1. What is point B? x2 comma y2. So what are A and B? Very nearer points, right? Whenever these 2 points are very near, then x1 is close to x2. x1 is very much close to x2, near points. x1 very much nearer to x2, and y1 is very much closer to y2, very much closer. These are also very much closer. So now what is the slope? Slope is equals to change in y by change in x is equals to y2 minus y1 by x2 minus x1. So this is the formula of slope. So right. So at this condition we can write whenever x1 is very much closer to x2, then delta x can be changes as dx. At this condition we can write delta x is equals to dx. Delta x means there is a large difference between the 2 points 1 comma 2, 2 comma 3, but dx means whenever x1 tends to x2 and there is a small difference between the 2 points, then we are taken delta x is dx, delta x as dx. So this is called a instantaneous change. Instantaneous change in x. What is dx? Dx is nothing but what? Instantaneous change. Very small change. Very small change. This much change. This much change. So if y1 is very much closer to y2, then delta y tends to dy. Delta y change to dy. Is it clear? Write down this. Write down this. Pause the video and write down this. 3, 2, 1. Okay. So what we got? So delta x is comes to dx because since x1 is very much closer to x2. Okay. So delta y is equals to what? Dy, since y1 very much closer to y2. Therefore, slope m is equals to tan theta is equals to what is that? Dy by dx. So this dy by dx is called a differentiation. What is this? Differentiation. So it where where dy by dx is the instantaneous rate of change in y with respect to x. The instantaneous rate of change in y, sorry, the instantaneous. So what is dy by dx? The instantaneous rate of change of y with respect to x. So this is called what? Differentiation. Is it clear? What is the differentiation? Dy by dx is called a differentiation. What is the meaning of dy by dx? The instantaneous rate of change of y with respect to x is called what? Differentiation. So when the differentiation is exist, when the 2 points are very much closer to each other. Have a look. This is what happens. Is it clear? Any doubts? Write down. 3, 2, 1. Pause the video and write the notes. 3, 2, 1, go. Right. Now we understood what is differentiation. What is differentiation? The instantaneous rate of change of y with respect to x is called a what? Differentiation. Okay. So the formulas of differentiation. Formulas of differentiation. Okay. So first formula. If y is equals to constant, if y is equals to constant, okay, then are you able to see the word? Okay, dy by dx is equals to 0. Okay, so if y is equals to constant, then dy by dx is equals to, the differentiation of constant is equals to how much? 0. Example, if y is equals to 2 pi, if y is equals to 2 pi, what is 2? 2 is constant. What is pi? Pi is also constant. Then dy by dx is equals to what? 0. Dy by dx is equals to what? 0. The differentiation of constant is how much? 0. Second one, y is equals to x to the power n. Y is equals to x to the power of n, where n is real number. N is what? Real number. Then differentiation of y, dy by dx is equals to n into x to the power of n minus 1. Dy by dx is equals to what? N into x to the power of n minus 1. So just put this n in front of x and subtract 1 from n in the power of x. Okay, just put the power n in front of x and from the power of this x remove 1. Have a look. Take an example. If y is equals to x to the power of 5, if y is equals to x to the power of 5, where n is equals to how much? Power 5. So dy by dx is equals to, what we have to do? Just put this power in front of x, 5x, and remove 1 from the 5. 5 minus 1, that is equals to 5 into x to the power of 4. That is the answer. Is it clear? Right. So next example. So if y is equals to x to the power of minus 3, y is equals to x to the power of minus 3, then its differentiation dy by dx is equals to, what we have to do? Put the power in front of x, and x to the power of, we have to subtract 1 from the power, minus 3 minus 1. So which is equals to minus 3 x to the power of minus 3 minus 1, how much? Minus 4. Is it clear? Right. Note, 1 by x can be written as x to the power of minus 1. Can we write like this? Okay. So if 1 by x square is there, we can write, if this x square come to numerator, then its power tends to negative sign. Then its power becomes negative. Are you getting? Right. Also, the root x, we can write root x as x to the power of 1 by 2. X to the power of 1 by 2. And one more note is there. If any if x power 0, if there is x power 0 means what? 1. We can write 1. Is it clear? So this is what? First formula, and this is second formula, and these are the example. Note, 1 by x can be written as x power minus 1. 1 by x square can be written as x to the power of 1 by x to the power of minus 2. So any okay, right. So third form, y is equals to log x. If y is equals to log x, then dy by dx is equals to 1 by x. Dy by dx is equals to how much? 1 by x. The differentiation of log x is how much? 1 by x. Note, if y is equals to log a b into x, if y is equals to a b into x, where a comma b are constant, where a comma b are what? Constants, then dy by dx is equals to, again it becomes 1 by x. Again it becomes 1 by x. Whatever the constants are there, they will removed, and you will get dy by dx is equals to 1 by x only. Right. It's a note number 1. And note number 2, if y is equals to log of ab by x, if y is equals to log of ab by x, what are ab here? Ab are the constant terms. Then dy by dx is equals to minus 1 by x. Dy by dx is equals to what? Minus 1 by x, because it is in a denominator. AB are removed, and we'll get minus 1 by x. Here 1 by x, because x is in numerator. Is it clear? Right. Fourth one, y is equals to e to the power of ax. So right. Fourth one, if y is equals to a to the power of x, if y is equals to a to the power of x, then dy by dx is equals to a to the power of x log base e into a, and dy by dx is equals to what? A to the power of x log base e a. Let us take one example. Y is equals to 3 power x. Y is equals to what? 3 to the power of x. Compare this and this one. Compare these two. At the place of a we have what? A is equals to 3. Then dy by dx is equals to 3 to the power of x, a to the power of x, 3 to the power of x, log base e, a. A is equals to how much? 3. Is it clear? Right. Fifth one. The fifth one is, if so, y is equals to e to the power of x. If y is equals to e to the power of x, then dy by dx is equals to e to the power of x. There is no change. There is no change in e to the power of x. Right? Okay, write down. Pause the video and write the notes, or take the screenshot. Your wish. Okay? Right. So, the term y is in a form of x sin x, x cos x, x into e to the power of ax. Likewise, we can use uv method. If y is equals to uv, if y is equals to uv, then dy by dx is equals to, then dy by dx is equals to v into du by dx plus u into dv by dx. V into dv by dx. That means first you have to differentiate the u term and leave the v term. Okay, and next you have to differentiate the v term and leave u term. Then you will get the answer. Is it clear? Also, it is also called as a dy by dx is equals to vu dash plus uv dash. So this is also called a uv method. Is it clear? Let's see some example. Okay, example. Same example, take the x sin x, y is equals to x sin x. Y is equals to what? X sin x. Find the dy by dx. Find dy by dx. Right. Solution. Choose v and u. I'm taking a u is equals to x and v is equals to sin x. Dx is equals to v u dash plus u v dash. So differentiation of u plus differentiation of v. Is it clear? So v, what is v? Sin x. U dash, differentiation of x. Differentiation of x is how much? 1. Plus u. What is u? X. V dash, differentiation of sin x. Differentiation of sin x is what? Cos x. So the answer is sin x plus x cos x. Is it clear? Any doubt? Right. So next example. Example number 2. If y is equals to e to the power of 3x into cos x. E to the power of 3x into cos x. Right. Solution. First, what we have to do? We have to choose u and v. Your wish, whatever it is. At this time, I am taking u as a cos x and a v as a e to the power of 3x. Okay. And dy by dx. Dy by dx is equals to what? V u dash plus u v dash. V u dash plus u v dash. Whatever it is, either v u dash plus u v dash, v u dash plus u v dash, whatever it is, because it is a plus term. How you will do? You will get the same answer. Okay. So what is v? E to the power of 3x. U dash, differentiation of u, differentiation of cos x minus sin x plus u. What is u? Cos x. V dash, differentiation of e to the power of 3x, differentiation of e to the power of ax, a into e to the power of ax. That's it. Any doubt? Any doubt? Right. This u by v method. Next method is what? U by v method. So u by v method is nothing but if y is equals to u by v. If y is equals to u by v, then dy by dx is equals to v into u dash minus u into v dash divided by v square. If y is equals to u by v, then its differentiation is what? Dy by dx is equals to v u dash. First take denominator and differentiate u minus minus u into v dash divided by v square, denominator square. Let us see first example. So y is equals to sin x by x. Y is equals to sin x by x. Find out dy by dx. Find dy by dx. So given what? Solution. So what is u in this given question? U is equals to how much? Sin x. V is equals to what? X. Then what is dy by dx? Dy by dx is equals to v u dash minus u v dash divided by v square. Okay. So which is equals to, what is v? X. What is u dash? Differentiation of sin x, cos x, minus u. What is u? Sin x. V dash, differentiation of x, 1 divided by v square, x square. Likewise, you have to solve the problems. Is it clear? Any doubts? Example problem is, if y is equals to e to the power of minus 6x divided by log a b by x. Log a b by x. Solution. What we have to do? First we have to choose u and v. At the place of u we have 6 e power minus 6x. At the place of v we have log ab by x. So what is the formula? Dy by dx is equals to what? V u dash minus u v dash divided by v square. V, what is v? Log ab by x into u dash. U dash means u is equals to e to the power of minus 6x. E to the power of ax, we can write a into e to the power of minus ax. A into e to the power of minus ax minus u. What is u? E to the power of minus 6x. E to the power of minus 6x divided by v dash. V dash means what? Log ab by x. Log of something divided by x. Log of something divided by x. We can write minus 1 by x divided by v square. What is v? Log ab by x whole square. Is it clear? Any doubt? Right. Let us discuss the one of the application of derivatives, that is maxima and minima. That means in a given graph or in a given function. So what is the point of maxima and what is the point of minima? We have to find. Okay. So finding maxima. Maxima means maximum and minima. Or these points are also called as a stationary points. Which points? Stationary points. And in physics we are called these points are equilibrium points. Which points? Equilibrium points. Okay, right. So to find out maxima or minima or stationary points or equilibrium points, whatever it is, we required higher order derivatives. What we require? We require higher order derivatives. That means till now we are solved dy by dx. Okay, that's it. Higher order means d square y by dx square, d cube y by dx cube. Just we use d square y by dx square only. Higher order means second derivative or third derivative, whatever it is. Important point. Note this. To find the maxima or minima, the first derivative of y should be 0. That means dy by dx is equals to 0. Always. To find maxima or minima, what we have to do? The first derivative of y should be equals to 0. So when we are did dy by dx is equals to 0, that dy by dx is equals to 0 gives stationary points. It gives what? Stationary points. Okay, let us say there is a function, let y is equals to f of x is a function. Okay, so I'm taking simply for example, and I made dy by dx is equals to 0. I made dy by dx is equals to 0. It gives what? Stationary points. Let it gives the stationary points. Let the stationary points are x1 and x2. The stationary points are x1 and x2. We got it. Let it be. Okay, right. Next, do this is a first step, and we got the stationary point. And the second step that what we have to do is do second derivative. Do second derivative of y. That means again we have to differentiate the equation whatever we got here. So that means what is the second derivative? D square y by dx square. Okay, again do do second derivative of y, that is what? That is equals to d square y by dx square. And substitute x1 and x2 values in this. What we have to do? We have to substitute x1 and x2 values in this second order derivative. If at x1 d square y by dx square I got greater than, is greater than 0 at x1, whatever it is your wish, less than or greater than. I got at x1 d square y by dx square is greater than 0. That means greater than 0 means what? It is a positive value. Then x1 is said to be minimum. Then x1 is said to be minimum value. Is it clear? Right. At x2 d square y by dx square is less than 0. I am substituted the value of x2. At x2 I got d square y by dx square is less than 0. Is less than 0. Then x2 is said to be maximum value. x2 is said to be the maximum value. So these are the steps to find the minimum and maximum values of a given function. Right. So the example is, if y is equals to 2x cube minus 3x square minus 36x plus 6, find out maxima and minima values. Find maximum and minimum values. What is our first step? For maximum and minimum, dy by dx is equals to 0. Okay. Then it gives what? From this we have to find x1 and x2. What is the next step? We have to make d square y by dx square. At x1, if d square y by dx square is greater than or less than or equals to 0, what is this? It is a minimum value. x1 is what? Minimum value. If at x2 d square y by dx square is less than 0, then x2 is what? Maximum value. So this is a process to find minimum and maximum values. Solution. First step, what we have to do? Dy by dx is equals to 0. So given function y is equals to 2x cube minus 3x square minus 36x plus 6. Now what is the first step we have to do? The first step is what? The first order derivative of y function is equals to 0. Let's we do the differentiation. 2 into x cube. Differentiation of x cube. What is that? X to the power of n. N into x to the power of n minus 1. 3 into x to the power of 3 minus 1. 2. Minus 3 into x square. X to the power of n. N into x to the power of n minus 1. At the place of n we have 2. 2 minus 1. 1. X to the power of 1 means x. Minus 36. Differentiation of x, we will get 1 is equals to 0. 36 into 1 is nothing but what? 36. Is it clear? 2 3s are 6x square minus 3 2s are 6x minus 36 is equals to 0. Let us say this is equation number 1. Okay. Now from this is what? First order derivative. What is this? First order derivative. Right? From this equation, I am taking a 6 common. We will get 6x square. 6. If I take a 6 common, we will get x square minus x minus 6 is equals to 0. Are you getting? 6 6 are 36. 6 into x is 6x. 6 into x square, 6x square. So if 6 comes to this side, it will get cancelled out. So x square minus x minus 6 is equals to 0. It gives what? It gives x1 and x2 values. Okay. So I'm finding the roots of this equation. That means x1 and x2 of this equation. X square. I'm writing minus x as minus 3x plus 2x. Can I write like this? Minus 3 plus 2 minus x. Okay. Minus 6 is equals to 0. From this, if we take x common, we will get x minus 3 plus, from here, if you take 2 common, you will get x minus 3 is equals to 0. From this, if we take x minus 3 common, x minus 3 into x plus 2 is equals to, we got the two values of x. What are those? X minus 3 is equals to 0, x plus 2 is equals to 0. Okay, so x minus 3 is equals to 0. If 3 goes to that side, it becomes x is equals to 3. X plus 2 is equals to 0. If 2 goes to that side, it becomes x is equals to minus 2. So we got the two values of x on doing dy by dx is equals to 0. Right. What is the second step we have to do? What is the second step? Do the second order derivative of y. We have to do the second order derivative. So where is the first order derivative? Here. 6x square minus 36x minus 6x square minus 6x minus 36 is equals to 0. So second order derivation is d square y by dx square is equals to 6x square. 2 6 are 12 into x square. 2 minus 1, we will get x. Okay. 6 2s are 12, x to the power of 2 minus 1, x minus differentiation of 6x, we will get 6. Differentiation of 36, differentiation of constant is how much? 0. So this is what we got the second order differential equation. Okay. Now what we have to do? We have to substitute x1 and x2 values, and we have to find at what value d square y by dx square is greater than 0 or less than 0. Okay. So at x1 is equals to, I am taking 3, and at x2 is equals to, I am taking minus 2. See, d square y by dx square, which is equals to 12 into, what is the value of x? 3 minus 6. 12 3s are 2 3s are 6, 3 1s are 3 minus 6. So that is equals to 30. So d square y by dx square is equals to how much? We got 30. It is what? It is a positive value. If we got positive value at x1 is equals to 3, then x1 is called what? Minimum value. X1 is called what? Minimum value. Or at x1 d square y by dx square is greater than 0. D square y by dx square is greater than 0. It is called a stable equilibrium. It is called what? Stable equilibrium. And it is also called as minimum value. Right? That means at x1 is equals to 3, at x is equals to 3, the function is what? In a stable equilibrium. So at x is equals to minus 2, d square y by dx square is equals to 12x minus 6. Substitute x value, that is equals 12 into minus 2 minus 6. 12 to the minus 24 minus 6. Minus 24 minus 6 minus 30. So d square y by dx square is equals to, we got negative value. Therefore, d square y by dx square is less than 0. Then the point x is equals to minus 2 is maximum value. Is what? Maximum value. Then it is in at a unstable equilibrium. Unstable equilibrium. And this point is called what? Maximum point. Is it clear? Right. So a graph is given like this. A graph is given like this. And there is a 2 points on this graph. Now we have to find which point is maximum and which point is minimum. Okay. Right. Observe the graph. First one, I'm taking point A. In this graph, the point A is at this position, right? Okay. So what is the formula of slope? dy by dx. This is the formula of slope. Okay. Now, if I draw the slope at a point A in this direction, if I draw the slope at a point A in this direction, in this side, I will get the slope like this. Okay. So if I draw the slope at point A in this direction, I will get the slope like this. Are you getting? The point A is at this position where the slope is what? Stable. This is what? Stable state. That means constant slope. Constant slope. Here the slope is constant. Have a look. Is the slope is positive or negative? Is the slope is positive or negative? See how to find? We have to draw the positive x-axis, and this is what? Y-axis. From positive x-axis, we have to take an angle theta in anti-clockwise direction. If this condition theta is greater than 90 degrees, then the slope is what? Negative. Slope is what? Negative. And if you come to this slope, draw the positive x-axis and a positive y-axis. Okay. Now from the positive x-axis we have to draw in anti-clockwise direction an angle theta. So where theta is less than 90 degrees and the slope is what? Positive. And the slope is what? Positive. That means in case of point A, the slope is decreasing. The slope is what? Decreasing. And after that the slope becomes constant. The slope becomes constant. Again the slope is increases. Again the slope is increases, right? So negative, positive. That means slope is moving from negative to positive. Slope is moving from negative to positive. Negative to positive. Slope is increasing. Slope is what? Increasing. That is dy by dx is what? Increasing. If dy by dx is increasing, then the second order derivative is also increases. That means it is greater than 0. When the second order derivative is greater than 0, point A is minimum point. Point A is what? Minimum point. Are you able to screen the board? Yes. Right. Point A is what? Minimum point. And this is also called as a stable equilibrium point. This is also called as stable equilibrium point. If you come to point B, now the point A is what? It is minimum point. Okay, na? Right, where the point is minimum. If you come to B point, the B point is at this position, right? So what we have to do? We have to draw the slope. Okay, we have to draw the slope at point B. This is a slope. Now the slope in this direction is this the slope. This is the slope is in this direction and this is the slope in this direction. Now, if you observe carefully, this is a positive x-axis and this is what? Y-axis. From the positive x-axis, we have to take an angle theta in anti-clockwise direction. Where theta is what? Theta is less than 0. Sorry, theta is less than 90 degrees. If theta is less than 90 degrees, slope is what? Slope is what? Positive. Then this slope is what? Positive slope. If you come to this side, see, this is what? Positive x-axis and this is what? Y-axis. Okay. So with respect to positive x-axis, the angle made by the slope in anti-clockwise direction is greater than 90 degrees. Whenever the slope is greater than 90 degrees, then the slope is what? Negative slope. That means at point B, the slope is like this. First it is a positive slope. After that it is in a stable state. The slope is at a stable condition. Okay. That means slope is constant. Sorry, the slope is constant. Then after what happened? The slope will be decreases. The slope will be decreases. Therefore, at point B, the slope dy by dx is tending to positive slope to negative slope, is tending to positive to negative. Then overall slope dy by dx. Initially it is decreasing, initially it is increasing, and finally what happened? The slope is decreasing. Overall, the slope is decreasing. The slope is what? Decreasing. If the slope is decreasing, then the second order derivative d square y by dx square is also decreases. Is also decreases. Then at B, at point B, d square y by dx square is becomes less than 0. D square y by dx square is less than 0. Then B is which point? Maximum point. Then B is called what? Maximum point. This B is what? Maximum. Is it clear? Any doubt? So pause the video and write the notes. Right. So this is the end of the today's session. We will meet in another session, the basic mathematics used in physics, class number 5. So in that class we are discussing about integral formulas. Okay, so practice all these things, differential formulas, and finding the maxima and minimum values. So in a given graph, where the point is minimum point and what is the point is maximum point, I hope that how to find all these things are cleared in this session. Okay, so my name is Rakesh Kanaganti, signing off. Jai Hind.